Hi class, this is our 10th online lesson and our first in this topic statics. See, after studying all that dynamics lessons, statics should be really easy because you're going to study the same forces, component of forces and everything again. The only difference is, in dynamics we were studying forces when the object was in motion. Statics, similar situation, we are going to study forces but the object will now be in equilibrium or at rest. A particle is said to be in equilibrium when it is acted upon by two or more forces and motion does not take place. This means the resultant force is zero and the particle will remain at rest. So this is the major difference: at rest, stationary, and it is not subjected to acceleration. This is the difference between dynamics and statics. In dynamics, the object was in motion. Here it will be in equilibrium. So basically the same formula that we studied in dynamics, the resultant force F equals to ma. Now the thing is, because the acceleration is 0, this side ma, 0 into anything is 0. So resultant force will be 0. So the net force is 0 and that is why the object will be in equilibrium, correct? So in other words, the leftward force on a horizontal plane, the leftward force will balance the rightward force. And similarly, the vertical force upward will balance the downward force. This is the main idea of the whole chapter. Okay, let's take some example now. First of all, this exercise 7a is all about component of forces. We have already studied this in dynamics, so no need to study again. It's the same thing. Okay, now let us take this question from exercise 7b in your textbook. A pitcher of mass 5 kg is suspended by two light inextensible strings. So there are two different strings. This is very important to note. There are two light inextensible strings. So because there are two different strings, they will definitely experience two different tensions. The tension on this string, because the strings are different, they will experience different tension. But however, in this case, because the angles are same, the two tensions will eventually be same. In other words, let us understand this with the help of all the forces. Let us draw all the forces in this scenario. Okay, because there is a mass, there will be a weight in the downward direction. We studied this in dynamics. And now because this is neither horizontal nor vertical, we need to resolve the forces. So the same thing, let's go horizontal, vertical. So this will become the vertical component of this force 10T, and this is the horizontal component, same horizontal vertical component of this. Okay, and now see, I have taken T and T same. Even if I would have taken this as T and this as S, and now if you look, there is one rightward force, one leftward force, and because the object is in equilibrium, they have to be same. The rightward force should balance the leftward force. So even if I write T here and S here, because this 2 will cancel out, T will be equal to S. So in other words, when the angle is same, the tension will turn out to be same. So that's why I just took T and T. And now see, if you see this, you see a Z here, this angle forming Z alternate angle. So if this is 45, this angle here where my pointer is now, this angle will also be 45. That's why this is opposite. That is why sine theta. Remember we did in dynamics, opposite will be sine, adjacent will be cos. So this is T sine, T cos, and same. Let's take the equation now. So if I resolve vertically, up as positive, okay, now here again this is not dynamic, so there is no F equals to ma. It is just the upward force will balance the downward force. You see there is an upward force here, you see my pointer, and there is an upward force here. This 2 and there is one downward force will balance this. That's why this plus this gives you 5g, and you'll get an equation. Solve. There is only one unknown T. One equation with one unknown, you just solve, you'll get the answer for the tension. The tension in the string is 34.6 Newton. Let's take another example. Now a particle of mass 6 kg hangs in equilibrium suspended by two light. Again there are two different strings, so tension will be different, and here the angle is also different, so tension will definitely be different. Okay, I want you to pause your video here and try to draw all the forces which are acting in this diagram and also resolve the forces. Okay, let us check now. So because there is a weight, there will always be a weight acting downwards. I have taken two different tension, T here and S here. We resolve, and if this is 45, this will also be 45, Z alternate angle. So if this angle is 45 where my pointer is now, this is opposite, that's why sine, this is cos. Again, if this is 60, this angle where my pointer is now is 60, so this will be sine, this is cos. The same thing we repeat again. If I resolve up to be positive, there are two forces in upward direction, so this plus this will balance 6g, so this plus this equals to 6g. There are two unknowns, so you'll have to use simultaneous equation. Now if I resolve rightward force as positive, this is the rightward force will be positive and this is left, so rightward force equals to this, or you can even write t cos 45 minus s cos 60 equal to 0, or you do this. Now there are two equations, simple mathematics, solve them simultaneously, you should get 30 Newton and 43 Newton. Let's take a new question. Okay, now a smooth bead. Now see, this is very important. Please make a note. I have put this in a box here. Bead, you know what is a bead? A bead is something where string can pass through. Okay, so that means it's a single string that passes through. There is a hole. A bead has a hole, so the string can pass through. So basically this is a single string, and obviously a single string cannot experience two different tension. So because the bead is single, they will experience the same tension, and there is an extra force here. Again, I want you to pause your video here, draw the forces, missing force, what the forces are acting in this situation, and also resolve the components and then check when you are ready. Okay, so there will be a weight mg. The component, this is 60, so this angle is 60, so this is opposite, adjacent, t and t, because it is passing through a bead, tension will be same, although the angles are different, doesn't matter. And there is an extra force, so there are two leftward force here, will balance the one rightward force. So I can say t cos 60 plus 2 will be equal to t cos 30, and the two upward force will balance mg. So I can say t sin 30 plus t sin 60 equals to mg. You will write the equation, solve on your own. Check the answer when you are done at the back. Let us take the next question. Same thing here. Try to do it on your own. You will see the diagram now, the forces. So please make a note. In this question they already gave you the weight. Weight is 2 Newton. So don't write 2g now. It's not mass. It is already 2 Newton. So this is 2 normal reaction like we studied in dynamics. If there is a surface, reaction force will always, because this is kept on a surface now, there will be a reaction force perpendicular to the surface. This force P needed to be resolved. So this is opposite. This is theta. So this is opposite. That's why sine theta, cos theta. Write the two equations, resolving upwards and rightwards. Solve the equation on your own. Next. Okay, a particle of mass 4 kg is held in equilibrium. Okay, equilibrium and on a smooth planes. What does smooth means? Yes, there will be no friction. Let us complete this diagram with the forces. You can try on your own before going ahead. Okay, so because the weight will always be downwards, 4 kg, and because the particle is kept on a surface, there will be a reaction force perpendicular to the surface. Okay, so this angle here is 90 degree. This P is resolved. Okay, and you remember again same thing. You see this Z, you go through my pointer. So there is a Z form. So this angle will be equal to this angle, alternate angle. So this is 45, opposite. So cos a sine, and this is adjacent. So P cos 45 is this. Same thing here. If this is 45, this will also be 45. So this is opposite. That's why sine. This is adjacent. So cos. These are all the scenario. But again, take this as your x-axis. Look at my pointer direction now. This is your x-axis or the horizontal axis, and always take R, this as your vertical or the y-axis. So horizontally there is one rightward force and one leftward force. That's it. So this should be equal to this. Vertically there is R upward and this two forces, this one and this downward. So this plus this will be equal to R. Let us take them now. So P cos 45. Okay, in the question they're not asking us to find, then they're not asking us to find R. Yes, so I don't need that. So this equal to 4g, yani this horizontal force equal to this horizontal force will give you your P. If the question was to find R, then it was needed to use the vertical forces also. Let us take the next question.